We arrive in the second part of our tutorial, how to train your machine, transforming real data into digital knowledge for automatic processing. In the first part of our tutorial, we already learned about the basic information of machine learning, how we use the mathematical formula to extract a certain information from a data and then use that information to train the model, optimize the mathematical formula, and then use that to predict what happened in the other data in the future. In the second part, we will learn about how to do a data preprocessing, a process to extract a meaningful information from the raw data that we got. So the first thing we want to talk about is a concept called a garbage in and garbage out. The main concept of garbage in, garbage out have something to do with a specific question. Can we get a good result from bad data? Having a good data is a privilege, but sometimes the data that we have available online or as some form of information is raw data, which it takes some time or even a lot of process to transform the raw information into a good information or a good data that usable for the machine learning. So the idea is what happens if we use a bad data into the machine learning, and is it possible to achieve a good result with enough tries? Yeah, this is a joke from a comic strips a couple years ago about the machine learning system. You have a lot of data and big pile of linear algebra and try to do the steering. If the result is okay, yeah, it's good. If the result is not okay, that means you reuse the data until it's having a good result. But is it working though? Let's have a look on the training process itself. The idea of the training is you have the information and you feed the information into the machine. And there are several types of machine learning. A supervised learning, in which we give the answer to the machine about a specific pattern, or unsupervised learning, in which we ask the machine to learn the pattern by itself without our extra information to guide the result. But then, when the machine stop learning, there are several scenarios. The first one is when the machine achieves a good enough result. This is one of the best cases of the machine learning. It learns enough, having a good result, and in the future, when there are a similar data, a new data coming to the machine will be available to learn about it. But then there are three other scenarios that less than optimum to stop the machine from learning. The first scenario is when the machine has been running for too long, in which we can't run the machine forever. The second one is when the performance is not improving. Let's say the machine still has 60-70% of recognition rate, but then with the amount of time we spend to train the system, it's still not improving. That means there might be the limitation of the machine, or we feed them with the incorrect data. Or the last case is the worst one. Aside of getting the result to get better, it's starting to get worse. So the machine not only not adding the new information, but also forgetting the old information. In all the stopping condition scenario, only one is actually achieving a good result. The other three, not so much. So the idea is how we can improve the data preprocessing so the machine get the best possible input for training to minimize the bad stopping condition. And by using the good data, we hope to focus on learning the important pattern. So as a human, we already know which one is good, which one is bad, and we try our best to remove the bad pattern so the machine only learn about the good one. And because the machine has no intelligence in the beginning, that means all the information that we given to the machine, it will just process by the same thing, and it will affect the performance of the system. And cleaning up your data also keep the resource from learning the noise. While in some scenario the noise is there and we cannot remove it, there are several noise that actually uh, having a distinct feature that we can just throw it away straight away. And in the end, by using a good data, it will reduce the possibility of the learning to stop prematurely. That means the only way to stop the learning is when it achieves a good enough result. Database processing is the term that we use to format the data from the original raw information into the ready data that we can use to train the model. You can see there are several steps of the step-by-step process, starting from data gathering, discarding noise, fix incomplete data, and numerical conversion and normalization. Data gathering has something to do with finding the source of the data. Imagine if we want to work with the bushfire data, which part it has the best availability of the data that we can download, and it's always updated every year. And then with the updated data, we might be able to do another analysis, let's say the time series analysis or the other analysis that uh, won't be usable if the data is incomplete. The second one is what format we have for that specific data. There are several formats that usually available in an open data server. One simple format is the CSV, comma separated files, while there is another format that more complicated, or because it's represent the object serializable file. And in the end, that lead us on how to read and represent the data, because not all data can be used in its original form. Let's say we have a map data which usually have a height and width and even depth on it. If we want to train the model using the map data, we need to transform those information into the specific format that the model understand and know how to use it. The other data might need the process of discarding noise. What is it? The idea is raw data have the noise, all the data that's unusable. So we try to discard some of them to optimize the learning process. And of course, the data discard, when we want to discard the data, we need to first understand which problem we want to tackle, whether it's a supervised or unsupervised, because some of the different problem they need a different data. And how about the less relevant data? The less relevant data is a bit challenging because some of them might not have any meaning at all, but some of them, when they combine with another unrelevant data, they become a strong data. That's why we need to have a good understanding about both process, the data gathering and data discarding, to make sure that we keep most of the important data intact and get rid of anything else. The next important thing is how to work with incomplete data. During the data gathering, the original data gathering, there might be a case when the data is simply not there to for us to collect. So there might be some missing information, um, the blanks, or even the one that we call the outlier. The outlier means there is a problem with the data fields and the result is just um, impossible to get. So let's say about the salary, let's say we talk about the data of the monthly salary of ACD, and all of a sudden there was like somebody that get the salary of $1 million every fortnight. So while some of them might be true, most case it has something to do with the outlier. So how should we work with it? Do we fill the blank? Do we remove some of them? And how about when we have the situation when the data is really bad, and then if we remove most of them, we will lose a lot of important information. That's why to fixing incomplete data, we should look after we discard the noise, because we don't want to have more time to fill a blank data that in the end we just discard it anyway because it's a noise. And the last part of the data preprocessing has something to do with the numerical conversion and normalization. Why the numerical conversion? Because the machine learning is a mathematical process, and when you use a mathematical process, that means you need to convert all the information into a number, so the model will be easier to get to process them. As for the normalization, it's usually happened in the unsupervised learning, which is the clustering. The clustering usually happened by computing the distance of one key point to the other. And when we work with the multidimensional data without the normalization, some attributes just have a really big range that it will overshadow the importance of the other attributes. That's why using the normalization, let's say we normalize between 0 to 1 for all the information, they will have the same scale of comparison, and it will make the model to get a better understanding on the high level information of the distance, other than just using the raw distance anyway. So the next question is where to find our data. So if you just doing a Google search, you can simply put the keyword like the open data of a certain country. We can, let's say, the open data Australia, and one of the top result will be the data.gov.au. So each of the state in Australia, at least they will have their own data bank, and the data.gov.au is one of the collection place when the pull all the information using a single portal. And of course, if you want to look for the another open data, let's say in the US or UK, just use it. Most of the country that already use the internet as part of their data collection and data publishing, they will have at some point their own version of the open data. But again, what data do you need? It depends on what the application you will use it for. So most of the data will be on the raw format. That means it's better to find the best data that you really need and then work with all the pre-processing for that specific data to train the system. And of course, other than the open data from the government, you can get the data from the research data. uh, Usually you get the information from the research data from the paper or publication. So each of the research, they usually have the experiment, and in the experiment they will link the data that they used for uh, reproducibility. So yeah, you can use open data or the research data. Okay, let's have a look on the Australian data.gov.au. So let's say we want to look for the bushfire data. So we can work with the bushfire, and then we will have all the information that we can access. In here we have 230 results, although not all the results um, will contain a good amount of information. So we can say, okay, I want to check the location, let's say New South Wales. New South Wales usually have bigger data than the ACD, of course. And then, yep, and you can choose based on the organization, because the data.gov.eu is the pooling of all the information. So they will have a lot of organization actually sending the data to them. Or the format. The format is one of the most important things, because while there are several formats that we can use straight away, like a CSV, there are several formats that basically the export from the other system. Let's say for the uh, geographical information system, they usually use ArcGIS or some other information or some other proprietary software to work with the data. And then when they want to share the data, they will export the data using the format like the GeoJSON. But in this case, okay, let's say we choose the CSV or even the PDF or even the other thing on GeoJSON, and then we apply. And we will get some information that we can use. Some of them might be, we can use it straight away. Some of them might need more processing than the other. But then uh, when you look at the data, sometimes you also find the data like a PDF. PDF is basically the report and not too suitable for the data processing in for the machine learning. CSV is the simplest one, JSON is the second one, and XML might be okay, but a package like a PDF which already form as a report is a bit hard for us to uh, take in the information and process it. And of course, there are a lot of other information, like maybe some data they have the Excel but not here. So you just follow the link and then you download the data. And this is actually really good. The quality time series data. The time series data basically have the information updated over time. So by using a time series data, just thinking that you will have the complete data for a specific period of time. And by doing that, you can train the model not to learn based on one time frame, but also to learn the pattern from the multiple period of time. Let's say one of the data that we usually use the time frame is the regression data. Let's say we want to know what's the trend of the temperature in Australia. We can use a time series data and then we project what will be the highest temperature next year. The other one might have something to do with the housing price. Okay, let's see the housing price. Let's say housing price, any location. The format is okay. We clear the file first. We want to get the CSV. We want to get the where is it? Yeah, let's hit the CSV. So we will get, let's say, the median house sales, and when so this is the median information of the house sales from a specific area, and we can see we can have by suburb, and we can have the time series of the data, and of course some of them is on the XLS or Excels. The Excel is basically interchangeable with the CSV, but some of them might have the extra information that we need to clean first before we process further for the machine learning. And of course, there's another one called the Access Data API. So instead of downloading the data manually and then processing it and then training the model, we can get the data straight away from the database of the system. The good thing about that one is when using the API, uh, the data we get is the most recent data. So when the data is updated and we use the specific API, we don't need to uh, process the data again or checking whether there is a new data, because the API will handle everything. But yes, API basically they have their own standard and you need to access it by a specific way. Let's say this is for the Python, this is for the JavaScript, this is for the SQL statement, and so on. So that's basically it. So we're coming back here again to the slide. So we know how to find the data, and we can search the data, and hopefully we will find the correct one, either a time series or the usual one. And then we can download the data, process it, and based on the formatting, we might be able to get more or less information. Let's say the CSV and the Excel is similar. It's easy to read and process, but usually it's represent using row and column, which is very nice for uh, training the machine learning straight away. But the limitation is when you work with a multidimensional data, let's say the time series of the bushfire affected area. So sometimes there are data, the satellite image for the bushfire affected area for over time. So which parts got burned and which part is actually what's called grown again and getting lush again. So it's really hard for the data to be represented in the simple row and column like a CSV or Excel. And there are another type of data serialization format. Is basically you have the system, and when they want to dump the data, they don't want to follow the complicated process, because in the end the one that will use the log data, or basically the dump data, is the other system that will learn, get it and use it straight away, so without human intervention. So the data set is in format, usually using a tag or some formatting, like in JSON, GeoJSON, XML, or YAML. Some of them, they have their own format. At some point the human might be able to read it, but to get the details of each of the information, we need to do another preprocessing for it. And of course, there's a database format, which is we get directly from the database, either using the query or by accessing the API. So that's basically how you get the information. So you get the data, you discard the bad information, and then you fill the blank or discard the blank, up to you, and then you process with a numerical conversion or their process of normalization. And that's it. That's basically the whole process of pre-processing. So in the next step, we will have a demo about a certain data and how to use it to train a simple model. So this data is part of the challenge data from the Kaggle competition, and we will see that we might rarely to get this level of data, but at least it will give you the understanding of what process is involved of training the machine learning model. Before looking on the actual data processing and training, it's better for us to have a look on the type of the data that we got from the data.go.io. So this is one of the data. It's called the XML data. You can see that several of the XML, they have the version, and then there's like some information regarding the metadata, information regarding the details, and some of the information in the XML is encoded in a special way that it will link to the other, let's say this information. And if we look at the similar data in the form of GeoJSON, it will show us the other information, such as the longitude and latitude, longitude and latitude for a specific information, and what's the value that they have on a certain attribute, something like that. So same data, different format might have a different result. This is another one. This is like the median house price, if I'm not mistaken. It's like based on the city and the suburb, and what is the Q2 median, and so on, whether it's getting lower or getting higher. But imagine if you have time series data, which is now is the second quarter of 2019, and you have the first quarter of 2019, and you have the third quarter, fourth quarter, and by combining the data and with using the data preprocessing, you will be able to have a better understanding of what changed in the specific area or region, or even you can predict which area that will be affected when something changes. Let's say in ACD, what happened when the lead rails become available in the north? So the Ganglion area, even the northern part of the Canberra, now become one of the higher pricey area in the term of the rent. Before, they're so far from the city, but with that current trend, we can predict which area is actually getting a high rise or the lower price during the year. So that's if you want to work, let's say, with the financial system or with the transportation system, it might be useful for you.